Welcome students to online classes of mathematics for class 8. In this video we are going to study the chapter number 5, which is data handling of NCERT textbook, and we'll try to cover the exercise 5.1. This is our session number 2 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. In previous session we have discussed about the graphical representation of data. We have four methods here, which are pictograph, bar graph, double bar graph and histogram. Okay, based on this we have the exercise 5.1, in which we are going to use this four type of graphical representation. So let's start the exercise 5.1. Okay, this exercise in total have only 5 questions. We'll do all the questions today in this video. So first question is, we are given certain data and we are asked for which of these would you use histogram to show the data. As I told in the previous class that in order to represent a data by histogram we need continuous class intervals. Okay, to represent a data with the help of histogram we need continuous class interval. If we can divide our data into class intervals, continuous class interval, only then we will be able to represent it using histogram. Otherwise we cannot represent the data using histogram. Okay, so we are given certain statements here, so we need to state for which we can use the histogram. So the first one here is the number of letters for a different area in a postman's bag. So can this be represented by the histogram? Answer for this one is, let's write it here, part A. So since we have the number of letters for different area in postman's bag, suppose there are 4 localities, like say A, B, C and D. Okay, for locality 1, the postman has certain letter, let's say 20. Here he has 20, 30, 15 and 25. So these are the number of letters that postman have for 4 different localities. So clearly you can see we cannot divide this data into the class intervals. Okay, so this cannot be represented by the histogram. We can use bar graph here. Okay, so answer for this one is no, we cannot represent this data using histogram okay, because the number of letters in postman's bag cannot be divided into continuous class interval. Okay, since we cannot divide this number of letters into continuous class intervals, so we cannot represent this using histogram. Okay, so that's the answer of question number 1, part A. Now moving ahead to the part B. The statement here we have the height of competitors in an athletic meet. So question is, can we represent this using histogram, the height of competitors in an athletic meet? Okay, so answer for this one will be yes. Why yes? Because the height of this competitor in athletic meet can be divided into range. Like if we count it in centimeter, there can be a person who's we can divide it into interval, let's say 160 centimeter to 165 centimeter, 165 centimeter to 170 meter and so on. So this data can be divided into continuous class intervals, so that hence this can be represented using histogram. So answer this one is yes, as the height of competitors can be divided into continuous class intervals. Okay, So answer for this one is yes, as the height of the computer can be divided into class intervals. Hence, this data can be represented using histogram. Okay, so answer for second part is yes. Third is the number of cassettes produced by 5 companies. The number of cassettes produced by 5 companies. Again, in similar way, if there are 5 companies, namely A, B, C, let's say there is another company D. Company A produced 20 cassette, company B produced 30 cassette, company C produced 15, and D 25. Let's say E produced 50. Again, there is a certain fixed data for every company, so this also cannot be divided into continuous class interval. We can use bar graph here but not the histogram. So again, the answer for this one is no, because the number of cassettes produced by 5 companies can not be divided into continuous class intervals. Hence, this data cannot be represented using histogram. Okay, so the answer of part C is no, because we cannot represent this data using histogram. Now moving ahead to the next one, we have the number of passengers boarding train from 7 a.m. to 7 p.m. So that means we have total 12-hour span. So we can divide the number of passenger boarding into train into class intervals. See, like this: from 7 a.m. to 8 a.m., then 8 a.m. to 9 a.m., and so on till evening 6 p.m. to 7 p.m. Okay, this is a.m. and we continue to 8 till 6 p.m. to 7 p.m. So that means we can divide this data into continuous class interval. So again, the answer for this one is yes. Yes, because the number of passengers boarding the train can be divided into continuous class intervals. Hence, this data can be represented using histogram. Okay, that's because the number of passengers boarding the train can be divided into continuous class interval. Hence, this data can also be represented using histogram. Okay, so that's the answer of question number 1. Now moving to the next question, we have the shoppers who come to a departmental store are marked as: men are marked as M, women are marked as W, boys are marked as B, and girls are marked as G. All the letters in capital letter form. The following list gives the shopper who came during the first hour in the morning. Okay, since the shop opens in the morning, in the first hour of morning, this gives the data of the number of shoppers visiting the departmental store. So you are asked first make a frequency distribution table using telemark, and then we are asked to draw the bar graph to illustrate it. So our first thing is to draw or represent this data using frequency distribution table. So let's start this one. In order to represent this data using frequency distribution table, so first we have to make a table in which we will make 3 columns. Okay, so let's make a table first using pencil scale. Okay, you will use pencil and scale to draw this table like this, and we'll make 3 columns, one for the shoppers, second one for the telemark, and the last one for the frequency of the shoppers visiting the departmental stores. Okay, so let's complete this table. So that's a final table. Now what we're going to do is, in first column we'll write the shoppers, here we write telemark, and here we'll write frequency. Okay, the shoppers are the following. First we have women, represented by capital W. Then we have men, represented by capital M. Then we have boys, represented by capital letter B. And then we have girls, represented by capital letter G. Okay, now let's count the number of women. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. So the number of women visiting the departmental store is 28. Okay, so the number here is 28. So now we have to mark the tally marks, which will be like this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 and 28. And we'll write this frequency here, 28. Okay, like I have told you in the previous session that how to mark this tally mark. We'll draw the first 4 line, and the 5th one will be cutting the all 4. Okay, so then we move to the next same way. So the number of women visiting the department store in the first hour is 28. Now let's count the number of men. Okay, count the M's. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So number of men visiting the department store is 15. So let's write it: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15, and write the number here, 15. Okay, now let's count the number of boys. 1 2 3 4 5. Okay, there is only 5 boys, so write the tally mark: 1 2 3 4 and 5, and write the number here, 5. Okay, next we'll count the number of girls. 1 2 3 4 5 6 7 8 9 10 11 and 12. So number of girls is 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, and we can write the total here. So this 28 plus 12 will be 40, and 15 plus 5 is 20, so total will be 60. Now we have represented this data using frequency distribution table. Next we have to represent the same data using bar graph. Okay, so first we'll draw the bar graph. In order to represent this data using bar graph, we will draw 2 axes, one horizontal and the vertical, So let's first draw this vertical axis here and another axis which will be a horizontal one, and both should be at the angle of 90°. Okay, like I told in the previous class, when you draw the bar graph, the width of the bar and the space between the bar has to be equal. So let's mark the point at the equal distance. So let's say this is first gap, this will be for women, then another gap, this will be for men, then for another gap, then we have for boys one more gap, and this one will be for girls. Let's just extend this further. Okay, similarly we have to, on this axis we'll write the number of shoppers. So you can see the least data that we have is 5 and highest data that we have is 28. So we can mark the points on our this vertical axis according to ourselves. Let's take from 0 here, 0 to 5, 10, 15, 20, 25, 30, or you can take another little more gap. Let's say this one is 5, this one is 10, 15, 20, 25 and 30, and here we'll mark the women, here we'll mark the men, boys and girls. This axis will represent number of shoppers, number of shoppers. Okay, so the first we have number of women is 28. So in this bar will represent it till 28. As 20 is 5 is here, so 20 it will be 26, 27, 28, 29. So 28 is here. So you have to represent this bar up till this point. Let's use scale. So our first bar will be up to this height. Okay, so that's our first bar representing the number of women's. Next we have men. Men is 15. So 15 mark is here. So this will be up till this point. So let's connect this using scale to the baseline like this and close it from the upper side. This is 15. Number of men is 15. Next we have number of boys, which is 5. That means will be rise up to this point. Let's join it like this. And the last one we have number of girls, which is 12. So 10 is here, it will be 11, 12, 13, 14. So 12 is somewhere here. So this point will be marked up till here. Not here, it will be okay, it should be here. Let's give them a different shades. A shade like this for women. For men we'll give a shade like this. Boys dotted, and girls let's draw like this. Okay, let's write the numbers here. This one is 28, this one is 15, this one is 5, and this one is 12. So that's how we represent any given data using in the form of frequency distribution table, and from that we can represent data using bar graph. Okay, so that's the answer of question number 2. Now moving ahead to the question number 3, it says the weekly wages in rupees of 30 workers in a factory are given as, which is 830, 835, 890, 810 and so on till 840 here. Okay, so you are asked use telemark, using telemark make frequency distribution table with interval from 800 to 810 and 810 to 820. So as you can see, our least data here is, which is the least data, let's find out. We have least, or the smallest data here is this, I think 804. This is the smallest data that we have. Okay, and the highest data that we have is 890 here, 898. So the highest data is here is 890 and the smallest is 804. Okay, I think it's fine. Okay, so smallest number here is 804 and highest is 890. So we have to represent this data using frequency distribution table, and we are given the class interval to be taken as 810 to 820, then and so on till, as the highest number is 898, so we'll go up till 900. Okay, so again let's make a table having 3 columns. First one will be for the class interval, second one for the telemark, and the last one for frequency. Let's join this. Okay, so that's our table. In the first one we'll write the class interval, here we'll write the class interval, telemark, and frequency. Okay, as we are told that we have to take the class interval starting from 800 to 810. So first one will be 800 to 810, then 810 to 820, and so on for 820 to 830, 830 to 840, 840 to 850, 850 to 860, 860 to 870, 870 to 880, 880 to 890, and 890 to 900. So we don't have any data beyond for the greater than 900, so we'll stop there. So let's count the number of people getting the wage in these intervals. So first is from 800 to 810. So remember that, as I told in the previous class, the highest number will not be taken here. If we have any number which is 810, that will be counted in the next interval. Okay, so we have 810 here. So let's count from 800 to 810. We have this 804, 808, and also we have 806. So these three are lying between 800 to 810. So we'll write telemark as 1, 2, 3, and the number here will be 3. Okay, moving ahead, next interval is 810 to 820. So let's see, we have this 810 here, then let's see, and then we have this 812. We don't have any other number between 810 to 820, so the tally mark will be 2 and the frequency will be written here as 2. Next is 820 to 830. 820 to 830. So let's count. The first we have is this 820 and so we have only one number here. Frequency tally mark will be 1, frequency is also 1. Next we have 830 to 840. So we have so many from this category: 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total we have 9. Tally mark will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9 here. Next we have 840 to 850. 840 to 850, let's count. So this first, second, third, 4 and 5. So its number is 5 now. Let's write it here. 1, 2, 3, 4, 5. Tally mark will be 5 here. Next count in 850 to 860. So in the remaining one, 850 to 860. So we have 1 here, 2, only 2. Let's see 850 to 860 again. So this will not be counting here because this will be counting in the next one. We have only one, which is 855. So let's write 1 and frequency will also be 1. After this, next we have from 860 to 870. 860 to 870. Let's count. 1, 2, 3. Okay, that number here is 3. 1, 2, 3. Now 870 to 880. 870 to 880 is also 1, and we have 880 to 890 also 1, and 890 to 900 is 3. Okay, which are the last one is this 1, 2 and 3. So last one is 1, 2 and 3. Okay, so that's this frequency distribution table for question number 3. Okay, that's how we can represent this data using frequency distribution table. You have to count this number carefully. As it is given that the number of worker is 30, you can count the frequency and its sum should be 30. Let's see. 3 plus 2 is 5, 5 plus 1 is 6, 6 plus 9 is 15, 15 plus 5 is 20, 20 plus 1 is 21, 21 plus 3 is 24, 25, 20, 24, 25, 26. I think there are 4 of this one. Okay, because we have left this one here. So 1, 2, 3 and 4. So now you can see the total here is matching here 30. Okay, so that's the solution of the question number 3. Now moving ahead to the next question, we have question number 4. It says draw a histogram for the frequency. Draw a histogram for the frequency table made in question number 3. That means this table which we have made in the question number 3. Okay, and answer the following question. So first thing is to draw a histogram for this above table. Like I told you, for histogram we need continuous interval. Now you can see we already have this continuous interval. That means this data can be represented using histogram. So in order to draw this using histogram, we need to draw two axes, one vertical axis, this one, and the horizontal axis, this one, and both should be at the 90 degree. Okay, so you can see here the highest data that we have here is 1, sorry, highest is 9 and the lowest is 1. So we'll divide this axis into accordingly. That means from smallest number is 1, so I'll start from 1 here, 2, 3, 4, 5, 6, 7, 8, 9, let's go up to 10 here. Okay, and on the bottom side we have, now you can see the lowest number that we have here is 800 and highest is 900. So we'll divide this horizontal axis between only 800 to 900. So let's say this one is 800, 810, 20, 30, 40, 50, 60, 70, 80. Let's extend this further, 90 and 900. So this is 810, 820, 830, 840, 850, 860, 870, 880, 890 and 900. Okay, one important thing that you have to notice here is that the data here starting from the number 800. Okay, and here we have 0. So you can see the gap between 800 and 810 is these 3 boxes, and between 0 to 800 is also 3 boxes, and you can see that this is not the equal spacing. So since our first data is starting from 800 and here we have 0, so what we're gonna do is we will make a zigzag line at the beginning like this. Okay, this will represent that the data between 0 to 800 is skipped. Okay, we have skipped the data between 0 to 800, so we'll mark this zigzag line. Okay, so now let's start using this table. Between 800 to 810 we have the number of worker 3. So between 800 to 810 we have number of worker only 3. So let's draw this. Okay, this is our first bar. Second, we have between 810 to 820, 810 to 820 is 2. So it will, next one will be rise up to only this point. Okay, so let's join this one. After this we have between 820 to 830 is 1. So it will be up till here. Next one is 830 to 40 is 9. So this time this bar will be raised up to 832. 840 will be raised up to 9. So it will be like this. Let's close this. Okay, next one is after 9 we have 840 to 850 is 5. 840 to 850 is 5. Okay, this would be up till here. Next one is 850 to 860 is 1. So this will be only up till here. Next 860 to 870 is 3. So this will be raised up to 0.3 here. And the last is 1 1 and 4. Next is 1 here, 1 here, and after last one is up till 4. Let's join all of them. Okay, like this. Okay, this is the histogram for the table that we have drawn in the question number 3, representing the number of worker here, and their wages here, and this is in rupees. Okay, so that's the solution of the question number 4. Based on this, we have to answer certain point. First one is, which group has maximum number of workers? So let's write its answer here. Which group have maximum number of worker? This is this group, which is 830 to 840. The group 830 to 840 has maximum number of workers. Next is, how many worker earn 850 and more? How many worker earn 850 and more? That means the number of workers beyond this point. Okay, so let's count. Here we have 1 3 1 1 and 4, so it will be 850 and more is 1 plus 3 is 4, 4 5 6, 6 plus 4 is 10. So the answer is 10 workers. Next is, how many workers earn less than 850? So first we are asked more than 850, now we are asked less than 850. So as this answer is for 10 and total worker is 30, that means remaining will be 20. Or you can check here, this one is 3 2 1 9 and this is 5. So this is 3 plus 2 is 5, 5 plus 5 is 10, this is 11, 11 plus 9 is 20. So the answer is 20 workers. Okay, so that's the solution of the question number 4. Now moving to the last question of this exercise is, you are asked the number of hours for which the student of a particular class watched television during holidays shown through the given graph. Answer the following question. So first one is, how many hours did maximum number of students watch the TV? As you can see, the maximum number is this. So the maximum number of students watch TV for 4 to 5 hours. Okay, so the answer for question number 5, part 1 is, the highest number of students watch the TV for 4 to 5 hours. Answer is 4 to 5 hours. Next one is, how many students watch TV for less than 4 hours? So less than 4 hours, that means the number before this point line. So if we have 22 plus 8 is 30, 30 plus 4 is 34. Answer is 34 students. And the third is, how many students spend more than 5 hours in watching TV? More than 5, that means beyond this point. So we have 8 plus 6, which is 14 student. Okay, so that's how we can answer the question number 5 using also reading the data from this histogram. Okay, so we have completed the exercise 5.1 or 5 question. Now what you have to do is, you have to practice all the questions multiple times so that you can understand them better and you can do them easily. Okay, so with this we have finished the exercise 5.1. So that's all for today's class. Thanks for joining here. Thank you.